In this video, you're going to learn about functions. I took some of these problems from the Prentice Hall Mathematics book, Algebra 1. To understand what a function is, you first need to understand what a relation is. A relation is a set of ordered pairs. The x values have some effect on the y values. A function is a type of relation. It's a type of relation that assigns exactly one value in the range with one value in the domain. So basically, a lot of people will say, for every x value, there can be one and only one y value. Let's look at some examples. So we're going to graph each one of these points, and then we're going to determine if this is a function or not. So x of -3 gives us a y of -9. What I would like you to do is do this on your own graph paper. So it'd be good for you to pause the video, do it on your own graph paper, and then watch. All right, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9. So this forms a parabola. We have a quadratic function here. And in this case, it is a function because if you look at these x values, every single x value has only one y value. It's true all the way down the table. Now you might say, well, -3 and 3, those are similar, but they're not the same x value. -3 and 3 are two different x values, and they each have their own y value. Let's look at number 2. In number 2, we graph -2, 0, we graph 0, 1, and we graph 0, -1. And the issue we have here is that an x value of 0 has a y value of 1. It also has a y value of -1, and that's not okay. So for every x value, such as 0, there can be only one y value. And in this case, there are two different y values. So this is not a function. Whereas number 1 was a function. Another example, number 3. When you look over here at x, you can see there's not a copy of x. We don't have x, the same x written twice, which tells you that this is going to be a function. Let's go ahead and graph this. 0, 1, 1, 2, 2, 4, and then finally 3, 8. And there's the picture of our function. Number 3 is a function. Number 4, however, is not a function because for every x value, there's not exactly one y value. There are multiple y values for the same x value of 3. So when x equals 3, y equals 0, 5, and 10. So it's not a function. So 3, 0, 3, 5, and 3, 10. So this is not a function. Next example. In this section, we're going to recognize whether a graph of a relation is a function or not. And we're going to use the vertical line test. If a vertical line can only pass through a relation one time, then the relation is a function. So if I draw a vertical line, and it only passes through one time, then we can say that this relation is a function. So this first example is a function. To save time, I'm going to write yes if it's a function and no if it's not a function. So yes, this is a function. Now I have to check to make sure that wherever I draw the line, it will only go through once. Because if there's any point where the line, the vertical line, goes through the function, or the relation I should say, at any point, then it won't be a function. Let's look at the next example. In this case, even though there's a place where the line only goes through the relation one time, there are other times where the vertical line passes through the relation 2 times. So no, this example is not a function. Let's look at the next problem. I draw my vertical line, and again, this vertical line should be perfectly straight. So I'm doing my best to draw it parallel to the y-axis. Make sure it's always perfectly parallel to the y-axis. When I'm drawing my lines, you can see that there's no line that will go through this relation more than once. So yes, this is a function. And the final example, when you draw some vertical lines, it goes through once. In some places, however, it goes through 3 times. Since there is a place where the vertical line goes through more than one point, this is not a function. So no, this is not a function. Some more examples. If I use the vertical line test and I draw vertical lines, wherever I draw a vertical line, it's only going to pass through this relation 1 time. So yes, this relation is a function. Over here, this one looks a little bit tricky, but if you draw perfectly straight vertical lines, you will see that yes, this is a function. Now you might be a little bit confused about this part because this part almost looks like it's going to become perfectly straight. But the truth is that it never becomes perfectly straight, so you'll never have a line go directly through it because I'll exaggerate it, but it's constantly approaching 0, but it never reaches it. So it's going to always have a curve, and when it has a curve, the line will never go through it. If it were a straight line, then a vertical line would end up going through more than one point. But this is constantly curving on either side. And it's approaching what we call an asymptote. So this is a function. In the next example, again, we draw our vertical lines. Those are not very good, but you get the idea. And yes, this one is a function. And the next example, even though there's a place where it only crosses, a vertical line only crosses the relation 1 time, it's still not a function because there are other places where the line goes through twice. If there's any place where a vertical line can go through the relation more than once, then it's not a function. So no, this is not a function. Let's connect this to what we were talking about when we were looking at tables. For example, let's look at 0, 2, and the point 0, -2. So you see here 0, 2, and 0, -2. What we said when we were looking at the table is that if there's a copy of x, then it's not a function. Basically, we're saying in a simpler form that for every x value, there can only be one y value. And for 0, an x value of 0, there are 2 different y values. So that is not a function. Now we have a rectangle, and this is not a function because it passes through twice here. It passes through, the vertical line passes through an infinite number of times on the ends. So this is not a function. In this next example, when we draw our vertical lines, there is no place where a vertical line will go through twice. So yes, this is a function. And this one as well is also a function. When you draw on your vertical lines, there's no place where the vertical line will pass through more than once. So yes, this is a function. All right, take a moment, think about it. Is it a function or not? Yes, it is a function because the vertical lines only pass through the relation 1 time. Now think about this one. Same thing. Yes, this one is also a function. And the final relation on this page, yes, this linear equation is a function. All right. A vertical line will only pass through this line 1 time in any place. So yes, it is a function. And this one right here, I want you to think about this one. It's a vertical line. Will this vertical line pass the vertical line test? And no, it will not. This vertical line passes through the original line an infinite number of times. It passes through every single point. So every single point in the vertical line that I drew and the original vertical line are shared. So it is not a function. No, it's not a function. Let's write down a few of these. So 3, 0, 3, 2, 3, -5, 3, 1 million. And what you'll see is that there's a copy of x. We don't want a copy of x. It's the simpler way of saying that for every x value, there can only be one y value. And in this case, 3 has many different y values. Now we're going to recognize whether a table is a relation or a function. I guess I should say whether the relation is a function because they're all relations. And again, we're going to write yes or no. So here, you see that there's a copy of x, and that's not okay. So no, this is not a function. 1 has a value of 3 and of -3. Number 2 is also not a function because we have a y value of 1 and of -1. For every x value, there can only be one y value. Here, we have an x value of -4, -1, 0, and 3. They each x value has exactly one y value, so that's okay. Make sure you notice it's okay if y is copied. Y can be the same the whole time. That's fine. It's still going to be a function. The problem is when we have a copy of x. Take a look at this. We have the same x value over and over again, which would be fine if all of the y values were the same, but all of the y values are different. Every x value should only have one y value, not 4 different y values. So no, this is not a function. Number 5, let's look at this carefully. -3, -2, -1, 0, 1, 2, 3. There are no copies of x, so every x value has exactly one y value. One and only one y value, so yes, this is a function. In number 6, 0, 1, 2, 3, 4, 5, 6, there's no copy of x, so that means every x value has its own y value. So yes, this relation is also a function. Number 7, all of these are unique, so that every x value has its own y value. So yes, this is a function. Number 8, quick, make a decision before I tell you the answer. This is not a function because an x value of 2 gives you a y value of 3 and a y value of 7. So it should only give you one y value, not two different y values. And in number 8, think about it before I tell you. Or, sorry, number 9. Number 9, yes, this is also a function because every x value has only one y value. There's no copy of x. Number 10, we have lots of copies of x. Every x value is only allowed to have one y value, not 4 different y values. So no, this is not a function. Number 11, yes, it is a function. We don't have any copy of x. And number 12 is not a function because for an x value of 50, we have a y value of 4 and of 7. Now we're going to start mapping relations. I'm going to save this till the next video.